All right. Another important part of your lab experience is your ring stand. This is called a ring stand. Traditionally, this would go together with a ring clamp, and that's why it's called a ring stand. But there are a variety of different clamps that you can put on your ring stand. We get a ring stand here in the laboratory. We find our ring stands underneath the hoods. This is a hood. There are 1, 2, 3, 4 different hoods in the general chemistry laboratory. This hood here, we have a switch on the side which will turn on a fan which creates a flow of air inside the lab out towards the fan, so we can work with materials that might, or chemicals that might smell bad or be caustic in the lab, in the hood here. All right. We also have a light over there. Underneath 3 of the hoods, the ones in the corners, we have ring stands. All right. It's labeled ring stands, and there are many different shapes, sizes. Basically serve the same purpose. Okay. For us, one of the main uses of the ring stand is to support our burette. Okay, this is the burette. This is a common instrument for doing titrations. The burette, very similar to a graduated cylinder, long, cylindrical, very narrow, so that we have a high degree of precision. Also, you can see that there are 10 marks between each milliliter, giving us a 1/10 of a milliliter of certainty, and then also the ability to estimate between those 1/10, which is going to give us 2 additional figures, significant figures beyond our decimal place. So if we get volumes larger than 10 milliliters, that gives us 4 significant digits to work with. All right? So to support the burette on our ring stand, we have a burette clamp. The burette clamp differs from other clamps that we have in our drawers. In our drawers, we have a variety of different, we have an S clamp and we have a pinch clamp, a variety of different clamps. If you use the wrong clamp on your burette, you'll increase the likelihood of it dropping and breaking or chipping. And if it breaks, then it's expensive, and that's a shame. So here's how we use our burette clamp. We clamp it onto the ring stand there. Here's our burette. The burette comes stored with deionized water. All right. You see how it has a stopper on the top, and it has what we call a rubber policeman on the bottom. The rubber policeman is this kind of a doodad like this. It's used for a couple of different things in the laboratory. Here we're using it to protect the tip of this burette. This is easily chipped, and after it's chipped is less useful. All right. This is the valve here. You can adjust how tight the valve is by tightening this nut right here. When the valve is parallel to the burette, then you have a flow. When the valve is perpendicular to the burette, then it is stopped. That's the way it is for valves in many different areas of science and any application. Parallel is, or perpendicular is off, parallel is on. Okay? So to start, we're going to empty out the water that's in our burette. We can dump that out. We can remove our rubber policeman there. All right. As we mentioned, when we refill it, when we're done with it, we want to store it exactly how we did with deionized water. All right. This is a chance we have to identify the different kinds of waters that we use in the laboratory. There's 3 different names, and really just 2 different kinds of waters. There's deionized water and distilled water. Deionized water and distilled water are the same components, but they differ in terms of how they are made. Deionized water means that it's water without ions, so it's just water, H2O, just molecules of water, nothing else. Distilled water is the same thing. It's just water, nothing else. You might have a little more carbon dioxide in the water if it's distilled water because of the process, but in general it's exactly the same thing. This here is what we call tap water. Okay? We don't want to put tap water in our burettes because tap water contains a little bit of salt that can build up residue over time, or maybe hard water in the burette. But filling the burette with water decreases that residue, and it also decreases the chance of getting dust in the burette. Okay, so if I wanted to fill my burette with a solvent that I've prepared especially for the burette, I can do that. I'll want to do it over the sink or over some sort of a tray if I'm working with something toxic or that can't go down the drain, so that I don't spill onto the counters. Here I have the material, the solution I've made, and I can pour it in nice and gently, nice and slowly. If I want, I can use a funnel, but it's not necessary. Usually I'm okay. If I'm working with something corrosive or caustic, then I'll want to be sure I'm wearing gloves. Okay? I fill it up as high as necessary. It's not necessary for me to go to the top always. Depends on how many volumes of, how many titrations I'm going to be doing. So here I have my burette almost ready to go. A few things that I'm looking for. First, this point right here, I see that there's an air bubble, right? The idea behind the burette is I measure how much I start with, and then I deliver some, and then I measure how much I've done, and I'll know how much I've delivered. Well, if I have an air bubble in here that's going to slowly be given out as I deliver liquid, then that means that the volume I delivered is not all the solution. It includes the air bubble. So I have to be sure that I get rid of any air bubbles before I take an initial volume. I can do that by filling it up high, opening it up, and making sure all the air bubbles come out. So now I see all the air bubbles have come out. I'm ready to go, right? And I can measure this here. When I measure a burette, I see that this starts at 0, meaning 0 milliliters have been delivered. This is 1, 2, and so forth. So it's counting down this direction. And again, I have 10 marks between there, so I should be able to have 2 decimal places beyond the milliliters that I measure. Okay, so now it's ready to go. I can put it into this burette clamp. All right, and position the burette. I want to make sure that when I release this burette clamp, I don't necessarily let go right away. I slowly let go to make sure it doesn't drop and chip the bottom. But now this is ready to go, and as I mentioned, I could take a flask with a stir bar in it and deliver my solution into that flask with that stir bar. I can use a stir plate to stir that stir bar for me. This stir plate, now I see I'm going to have to raise my burette a little bit. I raise it, let it settle, make sure it's not going to drop, and then I let go. Here I have my a stir plate. This stirs and heats. And I want to be sure I don't turn on the heat unless I want to. But in anything we're doing in our lab, we don't need to use the heat in Chem105. So I turn on the stir, and I can verify that my stir bar is centered close enough to the middle and that it works okay. It seems to be okay. So then I could take a solution of whatever it is I'm doing the titration of, fill it up. It's important that I'm stirring fast enough that anything that I drop in will be mixed well into solution. But if I go too fast, you'll see here, if you go too fast, then you can risk splashing, having splattering occur, and then the solution in here will be stuck on the sidewalls, and your titration will not measure that solution that's stuck on the sidewalls. If that happens to you, you can always take your squirt bottle and add some water to it. Again, deionized water. We take our squirt bottle, and because water is not what we're titrating what's in the water, sample that's in the water, we can add a little bit of water along the edges and rinse down any of the type or the solution that's splattered up because of our stirring too fast. Now we find a nice quick stir that seems to be mixing the drops from the burette with the solution quickly, and then we can begin our titration. Again, parallel means it's on and we're delivering solution, and then perpendicular is off. And you can control the solution flow to different degrees with how much you have the valve open. All right, so I deliver solution until my titration is done. I stop every once in a while, allowing the solution to equilibrate, meaning mix well, and then I can take my final volume and know how much I've delivered.
A titration is a controlled acid-base neutralization reaction. 20 milliliters of hydrochloric acid of an unknown molarity is added to a flask. 2 drops of indicator dye are added to the acidic solution. This indicator dye is clear in acidic solution and pink in basic solution. The burette is filled with a sodium hydroxide solution of known strength, and an initial reading is taken. The base is added to the acidic solution until the solution stays a slightly pink color. At this endpoint, a final reading is taken. The moles of base added equal the moles of acid present. This same reaction can be followed using a pH meter instead of an indicator dye. Initially, the pH changes very little as base is added. Suddenly, the pH changes rapidly as the endpoint passes. The solution quickly becomes very basic, and again the pH changes very little. The endpoint occurs at this middle point on the curve.
All right, so when I'm done, again, I take my solution, I put it back into the sample or the container where I had it, or I put it in waste depending on what kind of solution it is. And when I'm ready to store this, I put the rubber policeman back on, I fill it back up with deionized water near the top, use the stopper, and now it's ready to go. If I had some other solution in here, after I dump it out, I'm going to want to rinse it several times to make sure that it's ready for the next person. All right, so that is a burette again. It's a 50 milliliter burette, and it's what we use for titration.